Yes.
Oh, that's disgusting.
Okay, let me look at what time we're in class.
I'm not sure what it is.
Gross. Well, that's too beautiful right now. None of this
not gross.
means anything. It is gross and nasty.
Alright, so we're going to look at perhaps the most significant and most messed up of all derivative issues today.
Are we going to hate it?
No.
Yeah.
People mess this up a lot.
Is it called putting
Oh,
out?
you meant messed up like people messed up, not messed up.
It's kind of like
this is
not
awful.
distributing minuses. People mess that up a lot. Okay. So this is called the chain rule. So there were a couple times I think when you were taking derivatives so far where it would have been nice to know this because it would have shortcutted what we had to do.
But if you mess this
So
up a
another
lot, then
shortcut
you
on
really
top of the
want
derivative.
to.
Hopefully you guys won't mess it up a lot. I don't know, every class is different. So whenever a function, here's when you have to use the chain rule, right? Whenever a function has composition in it. So whenever a function that you want to take a derivative of, maybe once or twice or whatever, that you want a derivative of, has function composition in it, you have to do this. Okay?
What is functional composition?
Oh.
Sorry.
Whenever we have one function inside another,
Oh, yeah.
whenever we have, for instance, which one's inside which one there?
G is inside.
G is inside of F. And do you think they're going to explicitly show it like that most of the time?
Oh,
Functions are just inside each other sometimes, just the way it goes. For instance, let's think of a simple example. Like if you tried to take the derivative of sine squared of x, how would you do that?
Well, sin x times sin x.
Ah, so the only way you could have done it before was to do what? Rewrite it as...
Sin x, sin x.
So you could have said this is the same thing as sine x times sine x, and then when you take the derivative, what are you going to have to do with it?
The
The product rule, right? But there's a much faster way to do this derivative if you think of it as a composition. Sometimes you can't do anything but do that, so. This, what two functions are being composed in this example?
Sine of x and x squared.
Yeah, sine of x and x squared. Which thing is inside?
Sine.
Sine of x. Can't we write this like this? Isn't that the same thing? Really is. We just have the special notation for it, right? Can we clearly see what's inside now? What's the g?
Sin of x.
Sine of x, and what's the f?
Sine of x.
Squared.
I have no idea.
X squared. X squared is
Now it
f.
makes
That's
sense.
the outside layer. Okay? So you can apply the chain rule to this, and you don't have to use the product rule. It's nice. Okay, so what is the chain rule? Chain rule is real simple. It's not like hard to use. Watch.
Oh wait, we're
So
not
the
using
derivative of this, the derivative of f of g of x, and sometimes you're going to have more things. Let's write it like this. Sometimes you might have one thing inside another thing inside another thing. That's really, really common
It's
in
like
calculus.
G X.
G of f of h. We've had things we've looked at before like that. Okay.
Z of F of
Each time you have something inside, here's how you do the derivative. You just take f prime, just like you normally would, okay? You leave g alone, you don't mess with it. It's still inside, okay? But then the thing that everyone forgets is you have to multiply by something else. G prime. That's why it's the chain rule. You've got this chain that you're creating. If I have
So you
another
would-
composition, I'm going to have something else to multiply by.
So you would solve for G of X and then take the prime of that?
What do you mean
Like,
solve for
not
G of
solve,
X?
but
You take the derivative of the outside, leave the stuff inside it alone, and then multiply by derivative of inside stuff. Watch.
yeah.
Let's look at just page 130. Before we even do that, let's look at page 130 because they've got some examples there. I don't want to write them all down. There's a bunch. So when do we have to do this? I want us to look at some places where we're going to have to do this so we can start to recognize.
What 130?
130, please. While you guys are looking at that, I'm going to write down some examples. So you guys see, I don't remember where it's at on that page. Let's see. You guys see those four little expressions in the middle? So the ones on the left-hand column, do you need to use the chain rule? Look at them carefully.
No.
One at a time. Do you need to use the chain rule on any of those? But in the second column, they're almost the same. So things like,
The square root of x squared.
do we have one function inside another one there?
Yes.
Yeah, so
X squared
when we
inside
take the
of-
derivative, we're going to have to do something. Let's just do it on this one. So if this is y, let's just take the derivative of that. Y prime is, what's the outside function? Usually in calculus land, how do we rewrite this?
X squared plus 1 to the half.
Yeah, we go like that. Thank you, Mr. Bodino. Okay. So if I want to take the derivative, how am I going to start?
1/2
Take the derivative of the outside.
x squared plus 1 to the negative 1/2
There's f prime of g.
Wait,
Did I change the inside?
2x.
No, it's still just g. Now you got to do the extra thing times what's the derivative of the inside? It's easy.
2x.
2x. There we go. That's that derivative. You can simplify it and help me out.
1 over 2 parentheses x squared plus 1 to the, the square root of x squared plus 1.
You were still right though.
Well, the 2's can cancel.
2's cancel. So Todd's saying we got a 2 there. Put it there. Put the x there. Oh my goodness.
Wait, so it's just, so it was 2x over.
Over 2. So the 2's cancel. So that's good. We good? So I don't think using the chain rule's difficult. It's just you got to remember to use it. That's all. Okay. So you got to know when you have to use it and remember it. It's not a big deal. What else? So we want to do another one there before I look at some of my examples.
Yes.
6x, 3x plus
Sine of 6x. So we've got this question. The sine of 6x. When they write that like that, you have to know, uh-oh, when I take the derivative, I got to use the chain rule. If I call this f of x, and the derivative is, what's the derivative of the outside?
Which one is the outside on that one?
6x.
Oh, so x is the derivative?
No, it's
Wait.
cosine
So wait.
Outside is sine.
Okay,
So cosine of
6x
6x, leave it alone.
times
Derivative of
6.
inside is, we all know, 6. And we're always going to just do this in our heads and put that in front. I don't think we need to write that step down, do we?
Thank you.
That's an easy one. Okay. So a lot of people will say, oh, the derivative of that is cosine of 6x.
It's not.
It's not. It's just not. Okay.
6.
What's another one there? Oh, the next one's too easy. We know that that's a derivative one. How about this guy? Let's do x plus the tangent of x squared. Let's call that g of x. What is g prime? You guys help me.
Wait, hold on. Same.
1 plus secant squared x parentheses.
Did you use the
So wait,
Right.
which one's inside?
This is nothing, right?
Yeah.
The one inside.
Here I've got an inside thing, so I got to use the chain rule.
Oh, yeah.
Tangent's outside, so what's the derivative of that? Cassidy. Secant squared. What do I put inside that secant squared?
X squared.
X or x squared?
X
X
squared.
squared.
I think the thing stays the same, right?
Plus 2x times
Times 2x. Okay. The only way we could have done that before. Ooh, can we have done that before? No, we couldn't have. There's just no way we could have done that
x is
problem.
squared on the inside.
Yeah, like there would have been no way to get it x squared. Like we couldn't have simplified it. It would have just been can't do it. You know? Okay.
Or I think we would just put it.
So let's look at a couple more. And I think you guys will be set. Shall while I'm writing the other ones down, you guys do this one. This one's easy. Make that derivative, please.
Oh, God. So you did prime with the outside, right? And what did you just say?
Yeah.
So did you get? Just 3 though? Where's the? Wouldn't be 3x.
So we've already learned our longest derivative rule, the one that's the pain in the butt. We already learned it. Which one is that?
Bodhi, I, Heidi, O.
What is that
Quotient,
called?
the quotient rule.
Quotient rule. We've already learned like the worst kind of pain in the butt one. All the rest of them are just small. So this is just one people forget. That's all you got to be careful about.
Yeah.
Okay, so do you guys do that?
Oh, because you subtract 1. Yeah. So wait, is that?
We still got some more to learn after this, but they're small.
That's called the theta for the derivative.
We have 8 more, and that's it. That's all we're gonna learn.
7 times 2.
I think.
How many more?
8.
8? It's not me.
No, and they're all simple.
So is it 2x?
Then we'll get to start using them for stuff.
Enjoy.
Did we get number 1?
Mm-hmm.
It's pretty easy, isn't it? What is it? Not Caitlin.
3.
Wait.
3,
3?
parentheses, x squared plus 1, close parentheses, squared. What? You didn't say
Okay.
the name, did he?
Times 2.
It's fine. Keep going, Austin.
Times 2. X.
And I can rewrite that way better. Bring those to the front. Okay.
You have
Why?
y.
She's
Thank you.
I stopped because you started. It's okay, I don't.
I could not explain that to those Pueblo West kids. I swear they just didn't. I think you guys got it. Okay. Let's try this. What should we do first?
Pull the 2t minus 3.
Yeah.
Why did you get a square?
Here?
3 minus 2.
No, on the.
Oh, minus 1.
What's up with that?
Oh.
Square.
Because it's still
Stab
square.
Just stab it. Just stab it.
I just moved this here.
No, like.
Why is this square?
Oh, 3 minus 1.
Okay. Oh, so you
Because this is 3 to the same thing, and you decrease the exponent by 1.
See, I thought you moved down the square, not top, and I was like, where are you?
You okay?
I got it.
Okay. Good question. So we got negative 7 to the 2t minus 3 all to the negative 2 power. I'd simplify it like that first. Should I put g prime?
No.
Did I do a derivative?
No.
I did not. G prime is going to be
14.
14.
2t minus 3 to the negative third. Times
Now here's what everyone's going to forget.
times
No.
2.
Times 2.
So that is 28 over parentheses 2t, or the cubed root of 2t minus 3.
Cube root or to the
Oh,
third?
never mind, that's
Is
the
it
third.
32 times negative 7? Wait, isn't it? Yeah, it's the
It's
positive
the
3
third.
down there.
Do we agree with that?
Yep.
Are we going to forget this too?
Never.
Probably at some point.
I was truthful.
Try not to. Okay? I don't think you guys will forget it nearly as much as some others.
When were you teaching Pueblo West students?
Well, I was just helping them out. Those are our students, but you know, when Naomi and stuff was taking it,
Oh.
they had some issues.
I don't know.
3
3?
minus plus.
I didn't say
Or the squared is outside.
Okay, is this cosine squared or cosine of something squared? That's tricky, really. I think that's kind of tricky sometimes. Let's go like this just to be clear,
Yeah.
shall we? So we can think about it more clearly.
Yeah.
That's what that means, right? So, okay, so what's the outside function? I think let's just leave the 5 alone. The outside function is cosine.
Well, it will be signed.
Plus
It's going to be
5
plus 5 sine. Okay, good.
Teachers, please release the Rachel's Challenge students.
I already
I
know.
quit this year.
Okay. How's that? Am I done?
No.
What am I going to multiply by? Derivative of the g.
2 pi.
So this is going to be 2 pi
But doesn't pi go away?
I don't see how you count that.
x to the 1.
Oh, yeah, I do.
So there's 2 pi.
So just 2
2
pi.
pi x. Be careful though, that can be tricky. Watch it.
So when you have something like that, you took the derivative of the first term where you didn't have to use the chain rule, and then on the inside, or on the other side, you used the chain rule.
I had to use the chain rule how many times?
Once.
Let's be careful here. How many things are inside? We got the blue thing, that's 1.
Yeah.
Right.
Then
Technically, you
inside
used
that we have another thing. How many times did I use the chain rule? I used it once. Uh-oh, where's my other chain rule?
I don't understand.
That's because this isn't done.
Oh.
I don't understand how you did that then. Like,
Yeah. That was tricky, Mr. McGee.
I know, so let's do this again, okay? So, Positive 5 sine, are we okay with that?
Yes.
That's the first layer. Then we leave the inside alone. Still that same layer, okay? Then we multiply by the derivative of the next layer. Derivative of the next layer is 2 times pi x to the 1 power, right? Then there's another, can you see when I put those parentheses on there? There's another layer inside, so I still have to multiply by its derivative, which gives me another pi. Okay, so we had 3 layers this time. That last one was sneaky though, wasn't it? Yes, you have to be careful about what's inside of what. We forgot, because I didn't put those parentheses down, that there was still another layer to take the derivative of. Okay, so if we simplified this, we'd get 3 plus 5 sine pi x squared, and I should really do
10 pi squared x.
I just need more space. 10 pi squared x. You guys agree with Caitlin?
Wait, so we go. Yeah.
Does that make sense?
Where'd you get
You
this?
just brought all this over here. It's all being
10 pi squared
multiplied.
x. Where'd you get
2
that?
times 5, 10 pi squared x. Since they're all multiplied.
It's all multiplied, so she moved this all to the front, and that's what you guys all should be doing. That needs to be done. If that's not done, I will take points off. Because that's going to be, if you don't do that, it's going to get too messy. Could you take a second derivative after that?
You could.
It'd be
it
hard.
just wouldn't
It'd be
be
harder unless you moved this. If you moved this, it'd be a lot easier.
So is that a time symbol between your x and your sign?
Yeah,
Yes.
it is. You don't have to put it there technically.
No, I know. It helps me.
Yep. Okay, let's do this one. What time do we have? We have enough. Let's do maybe 2 more, and we're pretty much done. You guys will be ready for this.
Okay, well,
Okay? This one's subtly different.
it has a theta.
It's a sine squared.
Because of theta?
No.
No, isn't that a theta?
Yeah, it is.
So I was
That's not why I'm
right.
saying it's different.
I know, I was just kidding.
Theta
I know.
equals.
Just giving you a hard time.
Okay. Caitlin.
Hey, I think we better be clear about
1/2
this.
Sine squared 2 theta.
Just stab it otherwise.
Let's be clear about what's happening here. Is this what's happening here?
Yes.
Yeah.
It really helps, I think, to draw it like that. Okay? I should say rearrange it.
Draw it.
Okay, so 2 times a fourth. You guys agree 2/4?
Yeah.
Yeah,
No.
1/2. And then I've
That's
still
sine
got
squared theta.
sine of, is that squared theta?
2 theta.
Sine of
How'd
2
you get
theta
2/4?
to the 1.
Times.
I don't know, but the 2's still there.
Okay, I'm gonna do each color. Each color is a different layer, okay? There's the first layer. Now I multiply by derivative of the next layer.
Cosine of 2 theta.
2 theta, right?
Now I multiply the derivative of the third layer
2.
times 2.
Where'd you get that to?
Because when you take the derivative of this, you've still got a 2 that pops out because of the chain. You just ignore it. Okay, Austin, do you agree if you had cosine of 2 theta, what would the derivative be?
Would you bring the 2 out in front then, I guess, is what you're saying?
Yeah, but why? The derivative of cosine is
Sine.
isn't it a negative sign? And if you did that, you'd have an extra 2. This extra 2 has to be here. Okay.
So then you have sine 2 theta, cosine 2 theta.
Okay.
That's your
So you
answer.
could simplify this, yeah. You're saying what? Do what with the king?
Sine 2 theta, cosine 2
Half
theta.
times 2 is
1.
gone. And now we've got a sine 2 theta. Do we even need to write that 1? Cosine of 2 theta. Ooh, could we mess with identities on that if we needed to? I bet we could.
Yeah.
We're not going to, but I bet we could. Last one. One more. These last ones are really challenging.
Because it's 2 times 1, or 2 times a half.
X squared.
Okay, let's try that.
X.
Let's see. Let me see if my video's still going. You guys want to try it? Try starting it out. Start it out a little bit. And I'll help you simplify.
I'm gonna rewrite it.
Really good idea.
Oh, Austin's saying I'm gonna rewrite it, I like it. It's good. What are you gonna have to start by doing here?
I rewrote it.
You're gonna have to do push. The product rule.
Aren't you gonna have to use a product rule? Do you have one thing times another thing? One thing, other thing.
But how do you know when it's? But why would you use the product rule on number 4 when you have 1/4? It's like 1/4 times that.
Because 1/4 is a constant.
So
We don't have to
you
use the
just
product
go
rule on
away.
constants.
Because
You
inside
just,
of the
just stays out. Remember we had a derivative rule, Austin, that said the derivative of a constant times f of x is c times f prime of x.
Oh, okay. I remember that.
Okay, good question. Keeping us straight, keeping us honest. Okay, so product rule here, this isn't a constant. It's one function times another, so you gotta use the product rule. So first function times the derivative of the second, and that's gonna be the interesting part. 1/2, 1 minus x squared to the negative
Negative
1/2.
1/2.
Where's our new rule come in right now?
Times negative 2x.
Times negative 2x. There's the
I
chain
have
rule.
a question. How?
This whole part is just the derivative of that piece.
Oh, okay.
Okay, so
Yeah.
first derivative of second.
Plus.
Then plus
2x.
second,
Times 2x.
and Caitlin's saying derivative of first is 2x.
So, but then is there anything left on that one, or you only use the chain rule that one time in red?
I didn't have to use it on the other function because derivative of x squared is, there's no composition, it's just 2x.
Then you're going to get 2x root 1 minus x squared plus negative 2x cubed over 2 root 1 minus x squared.
How many x's do we have here?
2x cubed.
2x cubed? Cancel
Negative.
those. Negative x cubed.
Negative x.
1 minus x squared to the negative 1/2 plus 2x times 1 minus x squared to the positive 1/2. And that'd be good for now.
Wait,
Okay?
Why would-
Slow down.
Yeah, can we
Stick
move
that
Yeah, I
at
don't
the pace of
understand.
everyone?
No, I don't understand.
I feel so lost.
I just don't understand you got the negative x to the third.
Okay.
x
Do I need to
squared.
look
Wait,
at
how
this one?
much we?
Do we need to look at this again? Okay, this is,
I'm okay with the
Good
second.
measures.
let's call
No,
this
I'm fine with the
f
second
and this
part.
g. Are you guys good?
I'm fine with
I'm
the second
good
part. I
with
just don't
the
get how you got the negative x to the third.
Oh, so everybody's good with
I think we're
that.
good, yeah.
I'm good with the second.
2
So
on the
here.
bottom,
Third
2
part,
on the
yeah.
top, x squared. Multiplied
X
by
cubed? It's all multiplied, so I can
Oh,
scoot that
wait,
up
wouldn't it be
here.
negative 2x?
Negative.
Negative, but there's a 2 on the bottom and a 2
2
on the
over
top.
2 is,
Oh, okay, so it can't, okay.
Oh, so you did the.
So they
okay.
cancel.
yeah,
Okay.
okay.
Makes more
Now
sense.
you could do some fancy factoring with this. Or a
we just
common
leave it
denominator. Oh, I think we need to mess with
It's
it.
prettier if you had a common denominator.
Well, you're gonna need it next. You guys
Oh,
don't like to
that's
factor that.
disgusting.
X.
So I think let's
minus
use,
X
you guys like to
squared
make a common denominator, right?
Over.
Why do you go with this step?
So we'll go make a common denominator right here.
I'm so important for you.
And I wouldn't do this unless you needed it for something, but we will. So minus x cubed plus 2x. What does this part all become right here?
1 minus x squared.
Oh, 1 minus, yeah.
It's just itself, right? And then all over what's the common denominator?
2x over square root of 1 minus x squared.
There we go. Now can we make that a little nicer?
2x, so that's negative.
Minus 2x cubed.
Minus 2x cubed,
3x
yeah.
cubed.
Yeah.
Negative 3x cubed. Plus 2x.
So do you want us to take it all the way to that level, or?
I'd like you to attempt it, Cassidy, because, well, it depends. How well do you want to do on this exam? It's up to you.
I just want. Actually,
I could see you getting a 5, but it's up to you. The real reason you want to do this is because we're going to be setting this equal to 0 at some point.
And you're
How
gonna
did you
solve
cannot,
for
you
x.
cannot solve right here. We have two different terms.
Hi.
You cannot solve that equal to 0 until you make a common denominator. And then would I even have to look at the bottom at that point? No, and then I could do things like 0 equals factor an x out, right? And I'd have negative 3x squared plus 1. So one place that that's equal to 0 is 0, and then we could try to solve the other one. Did I make a mistake? Oh, plus 2, thank you. Then we could set the other factor equal to 0 and easily come up with that too. That's the main reason you need to do that kind of thing. Yeah, etiquette's nice too, but I wouldn't make you guys do it otherwise. Okay? But if you're getting to right here, you're doing pretty good. Alright? Alright, I think you guys are set.
When's the assignment gonna be due?
Tuesday.
Tuesday.
So you should be working on this. Get this almost done this week, and then if you have questions, we'll answer them in class. Maybe we'll present some on Monday. I don't think Tuesday we'll have time, so we'll present some of these in class on Monday and work them through and that kind of thing.
What are you doing on Tuesday? Just a lot of lessons?
I don't know yet, but probably.
They'll probably schedule something so we don't have class again. That's how it goes, right?
It's fine. We need to do this because he said we need to mostly done over the weekend. I don't want to do it over the weekend. Fine.
My weekend is so busy, it's horrible.
Shelter.
You need 4 things.
2 other things, but
It really sucks. Luckily, if your group doesn't do your work, you're not going to fail.
yeah.
As long as
Thank
you're
God.
working.
Cody Gookin and Tommy Davis to Student Services. Cody Gookin and Tommy Davis, Student Services.
Okay, so I have a little handout for you guys too on this one. It's just one problem. But
Is it a long seven?
I don't need your hand.
no, you guys will be fine with it.
Tell the story.
I'm not worried about it. I gotta go make copies though.
Go, he's listening. Oh my gosh.
Okay, I'm gonna go make some copies.
Brianna Dasher found his iPod Touch.
Oh God, no.
And she went to the pictures to see whose it was.
Tommy Davis's.
In one of them, he had his hand pulled like slightly down, where his hand lotion was kind of sticking out the top, and he took a picture of it.
It was a little bit more than a bush.
And then when
It
you
was like
saw
full
that,
on fern.
and then
Horrible.
he tried to get out of it and had swiped to another picture of his full blown everything.
Yeah. Just to say, the
I never looked at the
curtains do
same
not
thing
match
word.
the cabin.
I can't do it either.
The bell just rang? Are you serious?
I'm not going.
I seriously just got done. We have a 40-minute right next.
I'm not going.
You are going.
So since you Tuesday,
Can't
yeah.
make me.
I can't make you, Brett. I will grab you by the ear and drag you there.
That's a pretty big assignment.
Yeah, it is.
This is a huge assignment.
You're a huge assignment.
Yes, ma'am.
Okay, so I would have a look at this worksheet for sure. After some of those problems, I think you guys are gonna be fine with it. It's just like the graphical ones.
And a paper?
Follow the notation, just like you guys have been doing with those other ones. I bet we can get this done, no
I
problem.
have to.
Thank you. After hearing that story, you have to.
Yeah. Oh no, I've heard that story before.
It's really nasty.
It is nasty. Like you'll be walking and then you see
You
him.
can't
No,
stand the same.
and you see him in the hallway and you're just like,
I know, that's all
Are we gonna work on this?
Let me go back.
I'm gonna go write an essay.
I like the graphs.
First of all,
that's nice.
You guys have a good weekend.
You too. I'm gonna go see
I had so
Looper.
much fun getting
Pitch Perfect South Pueblo, so we're gonna go see
I
Looper.
know.